Hello, I am Sudarshan Nayak. Today again I present here to teach about the physics. Last class I told you about the velocity of light. Our topic was prism, refraction through the prism. When the white light, the light of sun, a radiation of sun, when passed through the prism, then its reflection takes place. Whenever the reflection takes place, there is equation comes, and that equation is known as the refraction through the prism. Refractive index mu prism equal to sine of delta m plus a by 2 upon sine a by 2. Here delta m and a is the terminology of the prism. When the light passing through the denser medium, after refraction first surface, the refracted ray just parallel to the base of the prism. In this case, the minimum deviation takes place. Whenever the minimum deviation takes place, incident angle on the first surface of the prism and refraction after second surface, and the reflected ray passed in the dense rarer medium passes the second surface, and after refraction second surface makes an angle emergent. So the emergent angle E and incident angle I is equal to each other in the minimum deviation. So let's go through about it. First of all, clean this one. Here we know that the velocity of light. This is velocity of light. Our velocity is here like this. This one is our velocity of light. Approximate equal to 3 into 0, 3.00 into 10 to the power 3 points. You can say the point 3.00 into 10 to the power 8 meter per second. This is the velocity of the light, white light, when the radiation takes place in the sun. So clean this one, and then we know about the more thing. Clean this one. Okay, enough cleaning up. Now we discuss more thing about the prism. As we know that when the white light travel through the vacuum or travel through the medium, slightly little bit change in the denser medium, but velocity of the denser medium and velocity of the rarer medium slightly difference. And when the white light changing their medium, rarer to denser or denser to rarer, in this case refraction takes place. So here is a prism. We know that the prism is placed in the air, rarer medium, like this. This is prism, and this is this is prism is placed on the table. Okay, table and prism is placed in between ear, in between ear, that is all around the ear, that is ear. Here it's mu a equal to 1.00. Okay, and it is denser, this is called denser, mu g equal to 1.5. This is just change, this one and this one is different, because we know that the material are different. Transparent medium, prism and air, both are transparent medium, but air is very rare. Its density is very less than the density of the glass. So there is something difference, there is something not, this is big difference, 0.5. So there is difference when the light, suppose that the light incident on this surface, this is the mu a equal to 1.00, or we know that the velocity of the light through the rarer medium like air is just equal to the velocity of the vacuum, or it is, velocity of the vacuum is greatest than other medium like glass, water, tarpaulin, oil, diamond. So the such kind of mediums, So here is fast surface, this is called angle of prism, and we know that A, B, C, triangular prism, triangular shape prism. A is called angle of prism. When mountain like this, table is base, this is base, B dash, C dash, and A dash. Here is the face. In the face, there are three faces. Always we know that when we taking the prism, it may be equilateral, either it may be isosceles. So here we take, if we all angle are same, like this, that's a equilateral triangular prism, and we take this prism, and this angle and this angle is equal, and another third angle is not equal to the other two angle, then it is not called equilateral, it is called isosceles triangular shape prism. So here is prism, a light incident at here, and here this is the medium, this is the change the medium, mu g, just like this. Here is point of incident, and this is normal, and this is normal, and this is called I. This is called I, angle of incident, fast surface of the prism. This is fast surface, this is fast surface A, this is the fast surface A dash, B dash is the fast surface of the prism. Okay, and this is the fast surface, light let travel from the rarer to denser. Here we have fast surface, and this one is traveling the ray. Suppose that ray is called here A, P, Q, R. This is the incident angle, this is the refracted angle through the denser medium of the prism, and this point Q is called known as angle of a point of incident. This, and this is normal. This is called incident angle, and you may say that this is the R. If we taking the fast surface, then we name this one is R1. R1 is nothing but the refracted angle in between refracted ray after incident and normal. This is the normal, this is the normal, this is normal, and this is the after refraction. It travel through the denser medium, and suppose that this is the parallel to each other, then it may be minimum deviation. So the angle between the refracted ray, so this is called refracted ray after refraction of far surface. After refraction of fast surface, this is the ray through the denser medium, through the denser medium. And this is the denser medium is what? This is glass, that is 1.5 or more than 1.5, that is called denser medium. Just difference from the air. So here is angle of prism. This is called the refraction. Whenever we study about the prism, then there is the refraction, minimum deviation, so many incident is here. Also when we know that it is a scatter process, when the light passes through the denser medium, the light is scattered. Also we know that refraction takes place. During the refraction takes place, the minimum deviation is taken. But we know about the minimum deviation. What is the reason behind it? So we know here is a pointed, this is delta m. Suppose delta m, this is called minimum deviation. Minimum deviation. This is a minimum deviation. Second, why it takes minimum deviation? When the light travels through the denser medium, that is the refraction. Refraction takes place. What kind of refraction takes place? If the prism is triangular shape, then there is the two mounted shape, mountain surface like this. This one is A dash, B dash, first refracting surface of the prism. Another A dash, C dash with the second mounted surface of the prism. And third is base. It is not there is no any role for the refraction, just based on the table. So two, here is the also here we draw this one here. This is the normal. This is the N1, and this is called N2. N1 first surface, N2 second surface normal. And when here this is the also form a point of incident, and this is called incident here. It means that the light ray travel through the denser medium and incident on the second surface of the prism. Whenever incident second surface and its refracted ray, we know that refraction takes place, the white light changing their medium, provided that there should be the difference, refractive index should be difference, then refraction takes place or phenomena of refraction takes place. So here is this is okay, and this incident here take place. This is the another point of incident, that is called R on the second surface, and this is the original path of the refracted ray after the refraction of the first surface. So it is reflected ray, but this after incident at point R is away from the normal. This is normal and this is the path of the refracted ray, because here is the phenomena of refraction takes place. Here is phenomena of refraction takes place. Then there is max and angle E. The last, after refraction on the second surface, the ray goes S direction. This is S, this is R, this is Q, and this is P. P, Q, R, S. This is the phenomena of the refraction through the prism when white light passes through the prism. Here is S, E and I. We know that E equal to I. If we know, then only then we can find the refractive index of the prism. But here is also, here is refraction. Another also we here is refraction, dispersion, minimum deviation, refraction, minimum, when minimum deviation takes place, there is the case is form here, like this. Third, this is I, angle of incident of the first surface, angle of incident on first surface is equal to E. This is the emergent angle of emergent on second surface. This is the, and here is also R1, and here is denser medium. When we naming this one, when the light is traveling through the denser medium and incident on this, we should not indicate the incident or angle of incident, because it is the denser medium. So it is a name R2, because R2 is the angle of the second surface. 2 means second surface. So here we consider R2. R2 is if we suppose here is, suppose this is the denser medium. This is the denser medium. This is the point. This is incident on here. This is incident. When the point is incident here, we can know that it is the incident point. So it is angle of incident. But here is denser medium. This is called denser medium. Due to this region, we consider this one is equal to R2. Okay, here is R2, and another, it goes in the rarer medium. Whenever it goes the rarer medium, and then it is the emergent after refraction of the R, and it is max and angle E. E is the emergent angle, and finally RS and normal, max and angle E. This E and this I is equal to each other. This is called minimum deviation. Here is minimum deviation. Due to minimum deviation, also when the minimum deviation takes place, the rays, the refracted rays through the denser medium just parallel to the base. In this case, here is refracted angle in denser medium, that is called 4. R1 equal to R2. R1 is nothing but it is the angle, refracted angle of the denser medium for first surface. R2 R2 is nothing but it is the angle of refracted ray. You can say that for fast surface, this is not refracted ray, this is the incident ray for the fast surface. Incident ray for the second surface and reflected ray for the like this. Suppose this one is prism and this is the point of incident. This is called incident I ray. That is called incident ray. When it is incident on the fast surface, there is the refraction takes place. This is called refracted ray. Okay, and it is reflected ray here, and it is for the second surface. This is also called, this is P, this is Q and R. R is the another point, and it is also point of incident on the second surface. When it is incident of the point of second surface, this is called incident. This is called I ray. I ray for the second surface. I ray for second surface. I ray for second surface. So refracted ray for the first surface and is equal to the incident ray for the second surface. We just name this one same. Refracted ray for the first surface, incident ray for the second surface. Both are same. So it is considered, this is the refracted ray R2. R2 we consider this one the refracted angle for the second surface, and this one R1 and R2 is equal to each other because there is minimum deviation takes place. This is the angle of R1 in the angle of first surface, first denser medium, first surface of the denser medium, first surface of the denser medium, and R2 is the angle of second surface of the denser medium. R2 is equal to angle of second surface of denser medium. So here is a refraction and minimum deviation. Why? What is the reason behind it? When the light passes through the rarer medium to denser medium or denser medium to rarer medium, there is the refraction takes place. We go through it. So first we rub this one, clean this one. As we know that about the light is the quantum theory. Light is the particle physics. Light is the quantum theory. It is velocity is very high all throughout the world. You can say throughout the universe. So it is a very high speed. So here is we know that about the energy of the light. Energy light means when we can see the light, but we cannot imagine there is light and it is the construction of light, and light is just visual. We feel it. Okay, so light is the visual things, and it is the electromagnetic radiation. Visual ray, it is called visual ray. The wavelength band 400 nanometer to 700 nanometer. So here is the band. Sun. Suppose this one is the band. This is called band. Visual. This is called visual ray. This is electromagnetic radiation. Electromagnetic radiation due to the sunlight. This is the electromagnetic radiation. If we go the ionization energy, we get the non-ionization energy. So here is non-ionization energy called. This is called infrared. Just longer wavelength. Okay, this is called 400 nanometer and this is called 700 nanometer. When this is just longer than, more than the wavelength, more than the red color, that is called infrared. Then microwave, just longer than IR, and then radio wave. Okay, and when the minimum less than the, this is frequency is greater and wavelength is decreasing. When wavelength is decreasing less than, this is called UV, ultraviolet, and that's X-ray, and this is called gamma ray. Gamma ray, that is called ray, like this. So this is the minimum deviation. Here is 7 color, construction of the 7 color, and in this band 400 nanometer to 700 nanometer, this is the wavelength range. If there is in between the 400 nanometer to 700 nanometer, that is called visual light, and that visual light is also known as the spectrum of the light, a spectrum of the electromagnetic radiation. It is the construction of 7 color, like visual. This is V, B, 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 Z, O. This is 7 color. 1, 2, 3, 4, 5, 6, 7. This is the red color and this is the violet color. This is the violet and red. This is the extreme color of the color band, that is called a spectrum. And when this light, this is C, this is called 2.99999 into 10 to the power 8 meter per second. It is approximately 3 into 10 to the power 8 meter per second. This light is passed through the denser medium like prism, then diffraction takes place. So that's it today's. In next class I will teach more detail about the refraction, minimum deviation, and thereafter we get the refractive index of the prism. So thank you so much. Keep tuned with me. Stay tuned with me.